Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we are going to study about the capacitance type level measurement. Here we will study the principle behind the capacitance type level measurement, its construction, its working and applications along with its advantages and disadvantages. So let us start with our topic. In industries, various types of liquids such as water, chemicals and solvents are used in the different processes. In different processes, we use different amount of liquids. Like we can use, suppose in one process we are using 2 milliliter of a liquid. In another process, we will be using 2 liters. So in different process, we use different amount of these liquids. So to find out the amount of liquid, we measure the level of the liquid which is stored in a container or a vessel. So we can say that for the industrial applications, the measurement of level is very important. So what is this liquid level, or what is this level of the liquid? How we can define it? So whenever we want to find out the amount of the liquid, what we will measure the level of the liquid which is contained in a container or a vessel. So suppose that we are given some amount of liquid, we are going to pour that liquid in a container and we are going to measure the level of the liquid in that container. Now how this level is being defined? Level refers to the position or height of the liquid surface above a datum line. That is, liquid level means that the height of the liquid which is above a reference line. Suppose that we are having a container, beaker or a vessel is there. We are given an amount of liquid. We are going to pour that amount of liquid in this container. So in this container, the liquid is filled. Now we want to measure the level of this liquid. So we are going to take this as our reference line. This flat surface of the beaker or the container is our reference line, or we can say the datum line. And the height of the liquid or the position of the liquid above this datum line, this height is equal to the liquid level, or we can say that this is the level of the liquid. So to measure the amount of liquid, it is required to measure the level of the liquid. So liquid level measurement is very important in the industrial applications. Now the level, it not only gives us the amount of the liquid, but it also affects the pressure and flow in and out of the container. So as the level is affecting the pressure and the rate of flow also, so that is why its measurement and its control become very important. So measurement and control of level is an important function in any industrial process. Now the level of the liquid, it can be measured by two methods. One is the indirect method and other is the direct method. So there are two types of method through which the level can be measured. In the indirect method, the level is converted into another signal and that signal will be measured. Means indirectly the level of the liquid is measured. Whereas in direct methods, we are going to get the direct reading of the level of the liquid. So in indirect methods, the level of the liquid, it is directly indicated by with the help of some mechanical devices. Example of the direct methods are floats are the mechanical devices, okay, through with the help of floats or sight glass method or dipstick. In earlier times, if we want to measure the level of the liquid, we use a length of a rod. We use a length of means a rod is being used. That rod is dipped into the liquid. We know the length of the rod, so with the help of that, we can measure the level of the liquid. So in earlier times or in ancient times, dipstick method is also used. Floats are also used. Float valves are there. Sight glass method is also used, and ultrasonic and radar, they are also a type of direct methods. So with the help of these methods, we are getting a direct indication of the level of the liquid. So direct reading of level is given by these methods. Whereas in indirect methods, the level is converted into another quantity and we are going to measure that quantity, and with the help of that measured quantity we can get an indication about the level of the liquid. So level is not directly measured, it is measured indirectly by measuring some other quantity. So in indirect methods, level is converted in a measurable signal using a suitable transducer. Transducer are those devices which convert a non-electrical quantity into an electrical quantity. So level is a non-electrical quantity which is converted into an electrical quantity at the voltage or the current. So we are converting the level into some other measurable signal and that signal is measured through the device. Examples of indirect methods are capacitance type level measurement, load cell, conductivity type level measurement, and hydrostatic head methods. So all these are the type of indirect methods. Now in the direct methods, if we are changing the material density, then the measurement is going to get affected due to the changes in the material density. Whereas in this indirect methods, the change in the material, it affects the measurement. In direct, it does not affect the measurement. In indirect, the change in the density affects the measurement. Okay. So these are the two types of methods which are used for the measurement of the liquid level. Now here we are studying about the capacitance type level measurement, which is a type of indirect method. In this method, we convert the level into the change in the capacitance. So we are not directly measuring the level, but we are measuring the change in the capacitance which is being caused due to the change in the level of the liquid. So we can say that it is also a type of transducer which is converting the non-electrical quantity into electrical quantity. Non-electrical quantity is the level and electrical quantity is the capacitance. Okay, so change in level is causing the change in the capacitance of the instrument. Okay. So the capacitance type level measurement, these methods are used, or the capacitance level sensors, they are used for wide variety of solids, aqueous and the organic liquids, and for the measurement of liquid level of slurries. Okay. Now this method is also known as the RF method, because in this method we use the signals which are radio frequency signals. So these capacitance level sensors, they are used to measure the level of the liquids which are having different dielectric constants. Okay. If we talk about its applications, then the capacitance level sensors, they can sense material which are having the dielectric as low as 1.1 like the coke or the fly ash, and as high as 88 like the water. So for different types of materials, either they are solids, they are in aqueous, or they are the semi solids, or the waste materials, waste liquid coming out from the industries, their level can be measured with the help of the capacitance level sensors. Also, these capacitance level sensors, they are the electronic devices. So phase modulation and the use of higher frequencies make these sensors suitable for those applications where we want to measure the level of the liquids which are having the same dielectric constant. So we can say that this capacitance level sensors, they are having a wide variety of applications for the measurement of liquid level for different types of liquids which are having different dielectric constant, and similar and liquids having similar dielectric constant, their level can also be measured with the help of capacitance level sensors. Of the capacitance level sensors. Now, if we define the term capacitance for a capacitor, then capacitance is given by the relationship. So, the capacitance of a capacitor is defined by the relation C, which is the capacitance, equals to epsilon A by D. Epsilon naught, it is the permittivity of the free space. A is the area of the plates, and D is the distance between the. So this is how the capacitance of a capacitor is defined. If we see a capacitor, if we see the construction of a capacitor, then it consists of two electrodes, and in between these electrodes we are having the medium, dielectric medium, which is called this dielectric medium is going to have a value of the dielectric constant. Now this medium, it can be either air, or it can be, means it can either be an air or any material, other material can also be used, or it can be a liquid also. Okay. Now when this dielectric medium is the free space, then capacitance is defined as epsilon naught A by D, where epsilon naught is the permittivity of the free space. Now if other than air any other medium is used, then capacitance is defined as epsilon A by D, where epsilon is equals to epsilon naught epsilon r. So this epsilon is equals to epsilon naught epsilon r. Epsilon naught is the permittivity of the free space and epsilon r is the relative permittivity of the medium. So if we want to measure the capacitance, we can measure it with the help of this formula epsilon A by D. Okay, we will have the value of the epsilon, that is the dielectric constant, A is the area and D is the distance between the plates, that is this. These are the two plates which we are having. Okay, now how this capacitance is used to measure the level of the liquid, let's see. Now as we have seen that in a simple capacitor we are having two electrodes, two plates are there. Okay, so for the measurement of level, so for we are measuring the level of a liquid. So for in that case we will be using an insulated electrode. That liquid will be contained in the tank. Okay, so tank wall is going to act as the another plate of the capacitor. You will clearly understand with the help of the diagram of the capacitance level sensor. This is the tank in which the liquid is being filled. So in this tank we have put an electrode here. So this electrode is going, this is an insulated electrode and this is the non-conductive insulating material. We want to find out the level of this liquid. Okay, so tank wall is going to act as one electrode and this electrode, insulated electrode, will act as one plate of the capacitor. So you can say that this is the capacitor. One plate is this electrode and another plate is this tank wall, and this level of the liquid is acting as the dielectric medium between the plates of the capacitor. So as the level of the liquid is increasing, the dielectric medium is also increasing, and as the level of the liquid is decreasing, the dielectric medium is also decreasing. So this is going to affect the dielectric constant of the liquid and it is going to affect the capacitance of the of this instrument. Okay, so as the capacitance, as the level is changing, the capacitance is also changing. So in this way we can find out the liquid level by measuring the change in the capacitance. So if you see that it is the capacitor, it is the tank wall, and it is the insulated electrode. Now in between it, if we are having this much amount of liquid, if in between these plates we are having only this much amount of liquid, so for that the capacitance value will be different. Now if this level is being increased up to this level, the dielectric medium is changing. Okay, the amount of dielectric medium between the plates is changing, so capacitance is also going to change. So in this way, the capacitance, it depends upon the level of the liquid. As the level of the liquid is changing, the capacitance is also changing, and this principle is used by the capacitance level sensors for the level measurement. So when the tank in this capacitive level sensor, when this tank is completely empty, then at that time the capacitance will be lower, and when this tank is completely filled, the capacitance will be more. So an empty tank has a lower capacitance while a filled tank has a higher capacitance, because filled tank is having the high amount of the dielectric medium, whereas an empty tank is having no amount of the dielectric medium, only free space is there. Okay. So that was the working principle of the capacitance level sensors. Now let us see that how these capacitance level sensors measure the level of the liquid. So, for the measurement of the liquid level, first of all, an RF signal is applied between the conductive probe and the vessel wall. Vessel wall means the tank wall, and the conductive probe means that the insulating the electrode which is dipped into the liquid, that is the conductive probe and the vessel wall. So, in between these two, an RF signal is applied. So this RF signal which is applied between the probe and the vessel wall, due to this RF signal, a very low current, it starts flowing through the dielectric process material in the tank from the probe to the vessel wall. So in the diagram you can see that we are having this probe, okay, and we are having the tank wall. So these are acting as the two electrodes of the capacitor. Now in between them we are applying the RF signal. So due to that RF signal, a small current starts flowing, and that current can be measured with the help of an electric circuit. Okay. Now when the level of the liquid, it drops in the tank, then due to the decrease in the level of the liquid, the dielectric constant also changes, also decreases, and due to the decrease in the dielectric constant, the capacitance also decreases, and also there is a minute drop in the flow of the current also. So if this is completely filled, if this tank is completely filled, then we are having a different value of the capacitance. As the level starts dropping in the tank, the capacitance is going to decrease because the dielectric constant is decreasing. So due to the decrease in the capacitance, the flow of the current which was flowing, that is also going to drop. So we can measure the change in the level by measuring the change in the capacitance, because in the formula we have seen that C is equals to epsilon A by D. Area is constant, D is the distance between the plates, it is constant. So only the dielectric constant is changing due to the change in the dielectric medium, okay, and this is changing due to the level changes. So we can say that the change in the capacitance is a direct measure the level of the liquid. So first we are going to measure the capacitance when the tank is completely filled. Then we are going to decrease the level of the liquid in the tank. Okay. So due to that the capacitance is changing. So change in capacitance is going to give us an indication of the level of the liquid. So in this way the capacitance type level measure sensors, they measure the level of the liquid. Now the measurement of the liquid by measurement of the liquid level by the capacitance level sensors, they are of three types. Measurement of non-conductive material, measurement of conductive material, and non-contact measurement. So measurement by the capacitive sensors, it can be measurement of the non-conductive material, means the liquid which we are measuring the level, that material is a non-conductive material, whether it's a conductive material, or the third type, that is the non-contact measurement. So first we will study the measurement of liquid level for the non-conducting material. So when the material or the liquid is a non-conducting material, there is no need of any insulation. So in that case, bare probe arrangement is used. Bare probe arrangement means that the probe is a type of lead, and this probe is being dipped in the liquid. So that probe is not having any insulating coating over it, because the material is non-conducting. It is not going to affect the flow of the current and anything. So bare probe arrangement is used. Also, the resistance of the material is very high, so it can be used as the dielectric medium. And in the formula, capacitance is equals to epsilon A by D. So area is constant, distance is constant. So capacitance is directly proportional to the dielectric constant or the dielectric medium. And dielectric medium is our non-conducting material. So we can say that the level of the material is directly proportional to the capacitance. Okay, so this is how the level of the non-conducting material is used, where bare probe arrangement is used for the measurement, and the liquid is itself acting as the dielectric. Second, measurement of liquid level for conducting material. Now here the insulated coating is required for the probes because the liquid is a conducting material. So if the probes are present there, so short circuiting can occur. So in this case, probe plates are insulated. To avoid short circuiting. Okay, so in the case of non-conducting material, no insulation is required for the probes, but for the conducting material, the probe plates had to be insulated. Now the third case is the non-contact measurements. Non-contact measurements are also known as the proximity measurements. Now in the earlier two measurements, the area of the plates and the distance between the plates is kept as constant. But in the non-contact measurements, area is fixed. Also, this method does not produce a linear output. Because you can see that not only the dielectric is changing, but also the distance between the plate also varies. So C is proportional to the epsilon, that is dielectric, but C is inversely proportional to the distance between the plates. So there is an inverse relationship between the capacitance and the distance. So the output is not a linear output, it is a non-linear output. And this method is used where the level of the liquid changes by several inches. So these are the three types of level measurement done by the capacitance level sensors. Now let us see some of the advantages and disadvantages and also the applications of capacitance level sensors. If we see the advantages, then they are inexpensive, versatile, reliable, minimal maintenance is required for them, contains no moving parts, so no friction problem is there. Easy to install and can be adapted to any environment. They are very easy to install and they can be adapted easily for the different sizes of the vessels. Rugged, simple to use. Easy to clean also. Good range of measurement. And they can be designed for high temperature and pressure applications also. So these are the advantages of the capacitance level sensors. Now comes the disadvantages. So if in the liquid we are having light density materials and also the particles with size exceeding the half inch in the diameter, so both these types of light density materials and particle sizes exceeding this, they can be a problem for the capacitive level sensors because of their very low dielectric constant, and this dielectric constant is going to affect the dielectric value of the liquid. Okay, so that is going to affect the readings which we are taken from the capacitive level sensor, because due to the change in the dielectric constant, the capacitance is changing. So these types of materials can be a problem for the capacitance level sensors. So that is the disadvantage of these sensors. Now let us see some of the applications of capacitance level sensors. As we are using them for the measurement of level, so they can be used for the measuring level of liquids. Not only the liquids but also the powdered and the granular solids, also the liquid metals at very high temperature, liquefied gases at low temperature, also the liquid level of the corrosive metals, and very high pressure industrial processes. So you can see that the capacitance level sensors, they are not only measuring the level of the liquids and solids and semi-solids, but also of the corrosive materials, of liquefied gases, of liquid metals, and all the liquids which are kept at very high temperature and very low pressures. Okay, so in this video we studied about the capacitance type of level measurement, where we studied the capacitance level sensors which measures the level of the liquid by measuring the change in the capacitance. We studied its principle of working, its construction, its applications, advantages and disadvantages. So I hope that this topic is now clear to you. Thank you.